Alright guys, in this tutorial we're going to be talking about atomic masses, how to calculate molar mass, and eventually how to find the mass percent of atoms in a given compound. So let's start out with the atomic mass. So in a given periodic table, along with having an atomic number, so the number that's going to be on the top of the element symbol is going to be the atomic number, and then the number below the atomic symbol is going to be your atomic mass. So you will be given an atomic mass in the given periodic table. So for example, in this particular case, if I'm looking at hydrogen, the atomic mass for the hydrogen is going to be 1.00794. And I'll talk about the units in a bit, but let me talk about how many decimal places you really want to keep. So to be on the safe side, in many calculations, it's okay to keep 2 decimal places for these atomic masses and molar masses, because if you carry all those 4 or 5 decimal places, it doesn't really make any difference in the calculations, but it's crucial to keep at least 2 decimal places, and there are going to be times when you have to actually keep more than 2 decimal places, or a matter of fact, as many decimal places you could, and that's the time when you're actually trying to find molar masses using isotopes. So for right now, if I keep only 2 decimal places, the atomic mass for hydrogen would have been 1.01. Now, what's going to be the unit? So the most common unit for the atomic mass or even the molar mass is going to be grams divided by the moles. Okay? Or you may see 1.01 AMU. So AMU means atomic mass unit, but not very likely used. Grams over moles is what's going to be used a lot. So what that really means is if I take 1.01 grams of hydrogen, that's going to be actually equal to 1 mole of hydrogen. And we'll talk about the moles later on, but that's what the common units we're going to be using for the atomic masses. If I talk about 1 atom of hydrogen, so 1 atom of hydrogen is actually going to weigh 1.01 atomic mass unit. But we don't really talk about 1 atom of hydrogen. It's more or less about the moles. That's how you express the numbers in chemistry, how many moles of particular stuff you have in a given compound. So keep in mind, grams over moles is the most common units we're going to be using here. So let's take another example. What if I say, what's the atomic mass going to be for, let's say, chromium? So chromium has a symbol of Cr, and you got to go and check where the Cr is in the periodic table. So Cr has the atomic number 24, which is going to be this right there. And if I keep 2 decimal places, it's going to be 50. Well, it's given 51.996. So if I round it up, it's going to be 52.00 grams per mole. Okay, so that's how you're going to be reading atomic masses. Now let's talk about the molar mass. So that's also very important. So if you're given an element, that's when you only focus on the atomic mass. Like for example, if you're given a carbon element, then all you really have to worry about is the atomic mass. But what if you're given a compound or a molecule? Then you don't really have an atomic mass, but rather you have a molar mass. So you have more than 100 plus elements in the periodic table that solely have only the atomic mass, but then there are thousands of chemicals, compounds, and molecules that have actually molar mass. So let me take a very simple example of sodium chloride. So sodium chloride is actually NaCl, so that's your table salt. So one sodium chloride has one molecule of sodium chloride, or you can say one formula unit of sodium chloride, has one sodium atom and one chlorine atom. So when I'm trying to find the molar mass of this, I would have to add up the atomic mass of the sodium and the atomic mass of chlorine. So what's the atomic mass of sodium? Well, if you look, sodium has atomic number 11. It's going to be 22.99 is going to be the atomic mass for sodium. That's going to be grams per mole. And then plus we have one chlorine. Chlorine is 17 right there, so it's going to be 35.45 grams per mole. So when I go ahead and add these up, it's going to be about 58.4, about 58.44 grams per mole. Okay, so that's going to be the molar mass for the NaCl. So the molar mass also have some other names, for example, molecular mass or the formula mass, and they will be interchanged. Sometimes you may see formula mass written or the molar mass written or molecular mass written. They are more or less the same thing. However, if what that really means, 1 mole of NaCl is actually going to weigh 58.44 grams in mass. So that's what literally it means. Okay, so let's take another example. What if I have assume sodium? Well, let's not take sodium. We already have sodium. Let's take aluminum sulfate. So aluminum sulfate formula is going to be Al2SO4 3. Okay, so to get the molar mass or the formula mass for this aluminum sulfate, we got to take care of all the elements that are in there. So I got 2 aluminum, so keep in mind you got to keep track of all the number of atoms in there as well. So I have 2 aluminum, so 2 times the atomic mass of aluminum, and if I go back and look up the atomic mass of aluminum, it's going to be, atomic number is 13, so it's going to be 26.58. Okay, so that's your aluminum. And then how many sulfurs you have in there? Well, I have 3 sulfurs. So when you have this 3 written outside the parentheses, that means it belongs to every single atom that's inside that parentheses. So you got 3 sulfurs. So it's going to be 3 times whatever the atomic mass of sulfur is. So sulfur is going to be atomic number 16, so its atomic mass is about 32.07, so 32.07. And then I have, how many oxygens we got here? Well, it's got 4 inside and 3 outside, so 4 times 3 gets multiplied, it doesn't get added, it gets multiplied, so it's going to be 12 oxygens in there, so 12 times 15.99 is the atomic mass for the oxygen. That's coming from the periodic table, obviously. Okay, so all we really got to do is just do this math here. So we got 2 times 26.58, and then I have 3 times 32.07, and then I have plus 12 times 15.99. Okay, it comes out to be 341.25, 341.25 grams per mole is going to be the molar mass for this aluminum sulfate. Okay, so then in addition, after being able to calculate the molar masses, you also want to be able to figure out what the mass percent of a particular atom going to be in a given compound. So let's say if I look at maybe sodium chloride, the question could have been asked, what's the mass percent of sodium in there, in sodium chloride? Okay, so that means I can set it up like this. So percent sodium will be equal to the mass of sodium divided by the molar mass times 100. So if you recall, the percentage, that's how you always calculate the percent. You take the parts divided by the whole thing times 100, and that's exactly what we're doing here. We're looking at the mass of the sodium divided by the mass of the whole compound, which is going to be the molar mass, times 100. Okay, so now we kind of go ahead and do this. The mass of sodium, which is going to be whatever the atomic mass is in this case, the atomic mass of sodium is, we have written down here to be 22.99. It's going to be 22.99 divided by the molar mass is 58.44 times 100. So whatever we get here, that's going to be the percent sodium by mass in NaCl. Okay, so that's about 39.34% sodium by mass. Well, if you have to calculate the percent of chlorine in there, how would you do that? The percent chloride, you can do the mass of the chlorine, which is going to be 35.4. If I go back, it's 35.45 is the mass of chlorine divided by the molar mass, which is 58.44 times 100. And that's how you're going to be calculating the the mass percent for every single atom that makes up that particular compound. So it comes out to be 60.66% chlorine by mass. Okay, if you have only two elements, let's suppose that if you have only two elements, like in this case, if you know the mass of one of them or the percent of one of them, you can calculate the percent of other one by simply subtracting from 100. So if I don't want to do this calculation and just calculate the mass percent of chloride here by doing 100 minus 39.34, because there's only two atoms in there. And if you already know one of them, then you can figure out the other one by subtracting from 100. So that's how you find the mass percent of the atom in a given compound. Let's take another example. What if I have an hydrate? Suppose I got this copper sulfate pentahydrate. So a lot of salt you see out there, they have some water molecules kind of associated with them. You don't really see the water in there, but it's more like a moisture, and those water molecules kind of crucial to give these salt to some amount of color. If you lose that water, then the color may change for that particular salt. Like in this case, copper sulfate has 5 water molecules associated with it. So if you have a salt that contains water with it, like in this particular case, it's called an anhydrous salt. Okay, and the anhydrous of that would be without water. So that would be just CuSO4. Okay, that means you have lost all the water. And what's the typical way of losing water? Well, if you just heat up this salt, this hydrous salt, and if you heat it up long enough, your water molecule will escape in the form of vapors, and what you're going to have left out is the anhydrous salt, which means it's without water. Okay, so let's try to calculate the molar mass here. So the molar mass of this hydrous salt is going to be copper. So let's go back and see what the atomic mass for the copper is. So if I go back, copper is going to be right here. So it's 63.55. So I got one copper, so it's going to be 63.55. We got one sulfur, that's going to be 32.07. We got 4 oxygen, so it's going to be 4 times 15.99. And I'm going to count the water as well. I just didn't write it all together, but it is a part of the molecule, so you want to make sure you add up whatever you get for the molar mass for the water. So in this case, you have 5 water molecules, so 5 times whatever the molar mass is going to be for water. So it's going to be 2 times 1.01, and then plus, there's 1 oxygen in there, so it's 15.99. Okay, so when I do this math here, so I'm just going to do this separate. So we got 63.55 plus 32.07 plus 4 times 15.99. and that gives you 159.58, and then plus 5 water molecules. It's going to be 90.05. So altogether, the molar mass for this hydrous is going to be 249.63 grams per mole. So the question could have been, okay, what's the percent of water in this particular hydrous salt? So mass percent of water, then I would do the mass of the water, which we already calculated that to be 90.0. So make sure you take account of 5 water molecules in there. So it's going to be 5 times 18.01, which gives you about 90.09-ish. So it's going to be 90.09 divided by the molar mass, which is 249.63 times 100. So that's going to be the mass percent for the water here. Okay, so it comes out to be 36.09% here. So what's going to be the mass percent of anhydrous salt? So you could say anhydrous, or you could even just say the percent of copper sulfate in there. So that's going to be, I can literally just do 100, 100 minus 36.09 because we already know one part, and it's going to be easier to calculate the other part here. So it's going to be 63.91%. Okay, well, let me make this question a little bit complicated. What if they ask you to figure out the percent oxygen in there? Okay, well, that's going to be the mass of the oxygen divided by the molar mass, which is 249.63 times 100. Now we got to go back and figure out what the mass of the oxygen going to be. You know, each oxygen is going to be 15.99. That's the atomic mass, but I got to go back and figure out how many oxygens are actually there. So if I look at this formula, let me change the color there. So there are 4 oxygens on this side right here with the copper sulfate, and then there are actually 1 oxygen on the water, but there are 5 water molecules. So there are actually a total of 9 oxygens. So you want to make sure you keep track of how many oxygens you have, or how many of those particular atoms you have in the given compound. So that's going to be 9 times 15.99 divided by 249. So let's say, okay, so after doing this calculation, it comes out to be 57.65%. So, more than half of the mass is actually coming from the oxygen, which makes sense because you just have so many oxygen atoms in this particular molecule. All right, so that's how you find the molar mass. That's how you look at the atomic masses, and this is how you find the mass percent. So it's very important to know all these factors before you start doing the mole concepts. If you have any questions, feel free to leave any comments in the section below.